Okay, guys, so as you can see, today we're talking about factoring out a GCF, a greatest common factor. Okay, we've already taken a look at some problems kind of like these, but as you can see with these problems, there's definitely some differences with what we're looking at today as opposed to what we were looking at earlier. All right, so we're going to go through these problems term by term. All right, we're going to see, we're first going to take a look at the coefficients. Okay, we're going to take a look at the numbers, and we're going to see if there's any factors we can take out, any numbers that we can divide by. All right, we called it shrinking. All right, and then today we're also going to look at the variables. Okay, because the variable may also be part of the GCF. You're looking to take out anything that all the terms have in common. That's why it's a greatest common factor. You're going to take out as much as you possibly can. Okay, so let's get started. So if we look at number one, okay, I started off really easy for you. Number one, okay, each of those terms has a 9 in it, as you can see. So it's pretty easy to see that you're going to be able to shrink this problem and divide all three of those terms by 9. So a 9 goes on the outside, okay? And in each of these terms, the 9 is really just going to cancel, okay? These 9s cancel, leaving you with n to the 5th, minus these 9s cancel, leaving you with an n. And then at the end, you got 9 divided by 9, which is 1. Okay. Now I mentioned the variables. Okay. The variables aren't a factor here with our GCF because not all of the terms have a variable. You can only take things away. You can only factor things out if they are a part of all the terms. So in number one, only 2 of the terms have an n. That last term doesn't have an n. So you can't take away an n. You can't factor it out. My final answer there is 9 parentheses n to the 5th power minus n plus 1. Okay. In number 2, okay, we're going to start with the numbers. We're going to start with the coefficients, then we'll take a look at the variables. Okay. Negative 20, 15, and negative 25. Okay. I'm sure you can realize that all three of those numbers are evenly divisible by 5. So 5 is going to be the number that I take away. Okay. Negative 20 divided by 5 is negative 4, x to the 8th, plus 15 divided by 5 is 3, x to the 4th. And then at the end, you have minus negative 25 divided by 5 is 5, x to the 2nd. Okay, so I got my number. I pulled my number out. And just take a quick glance at the new numbers you have, guys. I got 4, 3, and 5. You might just want to check them just to make sure you went high enough, right? It is possible that you start with a number and you're able to do it again because you might not find the highest number right away. That is possible. Okay, so take a glance at your new coefficients and just make sure that they're completely shrunk. There's no more common factors. In this case, they are. Now I'm going to take a look at the variables. Okay, I have an x to the 8th, I have an x to the 4th, I have an x to the 2nd. You can only take away what they all have. Okay, you can't take x to the 8th out. You can't factor that out because while that first term has 8 factors of x, this second term only has 4 factors of x. That last term only has 2 factors of x. You can only take away what they all have. In this case, they all have x to the 2nd, right? They all have at least 2 x's. All right, so basically, guys, the trick here is you look at your exponent. The greatest common factor, the one that you can take away, is always the smallest exponent because that's what they all have. All right, so that x squared is going to join that 5 on the outside. Okay, so that first term, I got negative 4. Now, I started with 8 x's. I factored out 2 of them, so you're going to be left with 6 plus 3. I started with 4 x's. I factored out 2 of them. You're left with 2 minus 5. Now, you started with an x squared. You factored out an x squared. So the x's in that last term are gone. So there's your final answer there for number 2. 5x squared, parentheses, negative 4x to the 6 plus 3x squared minus 5. Okay, number 3. Okay, let's say you're looking at number 3 and you look at the 81, the 36, and the 90, and you go, okay, those numbers are evenly divisible by 3. Okay, Negative 81 divided by 3, that's going to be negative 27x to the 6th. So I'm taking out a 3 here. Okay. Plus 36 divided by 3 is 12. X to the 5th. Minus 90 divided by 3 is 30. X to the 4th. Now, I did this on purpose, guys. I'm sure some of you guys, as you were watching me doing that, were going, whoa, 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 3's not it. 3's not the GCF. 3's not it. I know. I did that on purpose. Okay. You should always take a glance at your coefficients after you factored out what you think is the GCF and just make sure you went high enough. In this case, I didn't. These numbers, my new coefficients, are also divisible by 3. So I'm going to take out another 3. So this 3 is going to join this 3 on the outside. So really, guys, you're factoring out a 9. Okay. It's going to help you if you see that the numbers are divisible by 9 right away, because that will obviously eliminate that middle step. I'm just showing you this just to make you aware that it is possible that you can keep going. So don't stop until you've shrunk the numbers. You've taken out as much as you can. All right, so I got negative 9, x to the 6th. Now it's plus 4, x to the 5th, minus 10, x to the 4th. If I take a glance at those coefficients, I got a 9, a 4, and a 10. There is no number that will evenly divide a 9, 4, and a 10 other than 1. And I would never divide by 1 because that's not going to change anything. So I'm good where I'm at. Now you look at the variables. Okay, I got an x to the 6th. I got an x to the 5th. I got an x to the 4th. You can only take out what they all have. Okay, we said earlier that's going to be the smallest exponent. So I'm going to take out an x to the 4th here. So that's going to join the 9. Okay, I got negative 9 on the inside. I started with 6 x's. I factored out 4. That leaves me with 2 plus 4. I started with 5 x's. I factored out 4, so I'm left with 1x minus 10. I started with x to the 4th. I factored out x to the 4th. Okay, and you're done. Okay, so your final answer for that last one is 9x to the 4th, parentheses, negative 9x squared plus 4x minus 10. Okay, one thing I want to make sure that you guys are aware of here, okay? If you notice, if I go back to the beginning of these problems, we started with 3 terms, right? I had trinomials, 1, 2, 3, 1, 2, 3, 1, 2, and 3. When you factor out a GCF, okay, when you factor out that GCF, you should still have a trinomial. Okay, if you notice, I still finished with trinomials. They're different looking trinomials now because I factored out the GCF, but they still have 3 terms. Okay, that's not going to change. All right, you're not going to factor out a GCF from a trinomial and end up with a binomial. That's not possible. Okay, if it started with 3 terms, it's going to finish with 3 terms. Okay, hopefully this makes sense, guys. Good luck.